So here's the basic property or the equivalence of a logarithm of logarithm to exponent, and this is called, some teachers call it the equivalence, and some people call it the definition of a log. And here's what it is. This means, so here's what I write as a double arrow, which means this is equivalent to. This equation is equivalent to b to the y equals x. So here's the exponential, and here's the logarithmic, and you can go back and forth between them. So to start, let's talk about the different properties of logs, or of exponents, that we already know. We know this property. We know anything to the 0 equals 1. So let's go this way and tell me what the log property will be. What's the log property? If b to the 0 always equals 1, then log, notice how the base of the log is the base of the exponent. So the log of base anything of 1 equals 0. That's the log property that's related to this exponential property that we already know. Got it?
Yeah.
What's another property? I'll write the property and you think of the exponential or the logarithmic property that's related to. What's b to the 1 equal to?
B.
B to the 1 is equal to b. Anything to the first power is equal to itself. So tell me what the equivalent logarithmic property is. So this would be, again, let's take a look. Let's use color coding. There's my base, so that always goes in the base. The base always goes in the base, so it's going to be log base b. That's always going to go in the argument of the logarithm of b equals, and this is always going to go on the outside, equals 1. And let's think about that with the definition of log. Remember what the definition of log is? This to this power equals this. That's what the definition is. Remember, when I had 3 to the x equals 5, what I'm trying to do is I'm trying to find a way to write this equation so the x isn't in the exponent anymore. The variable isn't in the exponent. And the way to do that is to get that x down is to use logarithms. To rewrite this as a logarithm, this would be the log base 3 of 5 equals x. Now, if we only had a calculator that we could punch this into, and we do, then we could find out exactly what that is.
How do you get the base?
Okay. All right, so let's talk about how we can do this. Log base 3 of 5 equals x. Some calculators, depending on what you have, you will have a log base, like you can search for the log base x button, where you could define the base to be something specific. But there's an easier way, in my opinion, to do it. So I'll teach it to you. It's called the change of base formula. And here's the property. The log base b of a is equal to the log base 10 of a over the log base 10 of b. That's called the change of base formula. That's a really good one to know. So if you take your calculator and you punch in log, by the way, when I say log in your calculator, the button that says log and with nothing else is the log base 10. That's the standard logarithm in your calculator over the log of 3. Go ahead and tell me what log of 5 over the log of 3 is, and be careful with parentheses. Make sure that if it opens up the parentheses, make sure that you're doing it correctly.
1.5.
And your answer is going to be approximately 1.5. Whoops. 1.5. Whoops again. 1.5. Okay, now I'm going to show you one other thing. This actually isn't the real formula. The formula is the log base c over the log base c. It doesn't matter what your base is. It doesn't have to be 10. If you want to change the base, if you have an equation like that, or an expression like log base b of a, it doesn't matter what base you change it to, as long as the base on the bottom and top are the same. So let me tell you about another formula, or another function in your calculator, the ln button, that means the log base e. It's called the natural log. Okay, so when you see ln, that means log base e. When you see log on your calculator, that means log base 10. Right? So we're going to try something. Tell me what the ln of 5 over the ln of 3. If this is true, this better also equal 1.5.
What's ln?
ln means log base e. Alright, and again we get the same answer which we would expect, which is roughly 1.5. Now let me point this out. This number right here, remember what I was doing? I was solving this equation right here. I was solving the equation 3 to what power equals 5. Well, if I take 3 and I raise it to that power, which was, it was actually 1.46 something something something. If I raise that to that power, I'm going to get 5 back, or a number really close to 5, because that's what we're doing. A logarithm helps us solve an exponential equation with a variable in the exponent. That's the whole motivation behind what we're doing. So you're going to get problems in the future like this. You're going to get a problem like 3 to the x plus 2 minus 4 equals 7. This is not far off into your future, and you're going to have to solve this equation. So let's do that. We have enough information to solve it. What's the first thing I would do to solve this equation right here? The first thing I would do is how do I get rid of the minus 4? Right, add it. So it's going to be 3x plus 2 equals 11. Now, this looks confusing, doesn't it? Well, let's just convert it to a logarithm. This would be what? Log base what? 3, right? Because that's the base of what? 11. Remember, I go over here. Equals what? The exponent. You also hear a teacher say a logarithm is an exponent. See this right here? That is that. I'm almost done. How do I get x by itself? What do I have to get rid of? Is x by itself yet?
Yeah, no.
Not yet. I got to get rid of the 2. How do I get rid of 2?
Subtract.
I subtract it. So what's x equal to? Log base 3 of 11 minus 2 equals x. Now, how can I find out what that number is right there? Log base 3 of 11. Is there a log base 3 calculator or button in my calculator? Not really, but how can I find log base 3 of 11? Log of 11 over log of 3. That's the change of base formula. That'll give you the decimal approximation. So let's do that. Take our calculator, type in log of 11. Make sure you close the parentheses, divided by log of 3. And that's going to equal 2.1827 approximately. Minus 2. So what's 2.1827 minus 2? It's just going to be approximately 0.1827, right? Approximately. So I'm going to use my calculator, and I'm going to see if that works. I'm going to check it. You guys remember the store thing? Let's take this and let's store it for x. So let's go store. There's a button right on your calculator that says store, and we're going to store it into x. Okay? So when I store it into x, and now I punch in this side of the equation, 3 to the x to the x plus 2 minus 4, what should I get when I hit enter? I should get 7. And I do, because I did it right.